Yes. So now we move on to the problems. Before that, we shall have a quick recall about what we have studied last year from derivatives, the rules there, which the product rule, the quotient rule, and then the how to derive the function when it is in the sum of two functions and the difference of two functions. So if u and v are two functions, then if u and v are two functions, then u plus v d by dx of the derivative notated by what? D by dx. Right? Derivatives will be notated using u dash. The derivative of the function u can be written as u dash or du by dx. Right? Or u1, etc. etc. Last year we had also studied if y is a function of f of x, then the derivative is dy by dx. Right? Or f dash of x, or you can write it as y dash or even y1. All these are various notations of derivative. These are all our first order derivatives. Okay, we will deal with second order derivatives in the later sessions. That is, once you find the derivative, again you will find the derivative once again. That is the second order derivative. So these are the notations of how you will notate the derivative. All those things we have studied in class 11. That's why I am not moving much into that in a deeper session. I am just checking it. So d by dx of u plus v. What is d by dx of u plus v? That is du by dx plus dv by dx. Or you can even write it as u dash plus v dash. This dash notates the first derivative. Okay. Now d by dx of u minus v. That is what? Du by dx minus dv by dx, which is equal to what? U dash minus v dash. Both ways. Whichever way that you feel comfortable with, you can use. Now d by dx of uv. Now what we are going to use is the product rule. First function into derivative of the second minus second function into derivative of the first. Okay, that is u into v dash minus v into u dash. Next, the quotient rule. D by dx of u by v. Right? So, denominator into derivative of the numerator minus numerator into derivative of the denominator by the denominator square. So, this is the rules that we take into consideration while we use the derivatives, while we deal with derivatives. Okay. Okay, now let's start the problem of derivatives. We have the first question. F of x is equal to sine of this expression. This is a composite function, right? So how will we find the derivative? F dash of x. F dash of x is equal to derivative of sine x is cos x, right? So the entire term inside the bracket is taken as x first. So cos x. Now I will find the derivative of the expression inside the brackets. Now x square plus 5. What is the derivative of x square? 2x. Now do you have the derivative for 5? It is 0. So here you have this as 2x cos of x square plus 5. Am I clear? That's all. Now the next one, f dash of x. What's the derivative of sec x? Sec x derivative is sec x tan x. So children, you have to study the formulas. Only then you will be able to do both the differentiation as well as integration. Now when it comes to integration, only if you have thorough understanding of differentiation, you will be able to move into the integration. Okay, so study the formulas clearly. So f dash of x is equal to integral of sec x is sec x tan x. Here in place of x I have tan root x. So sec x tan x. Tan x value is what? Tan root x. Right? Now over again I have to find what is the derivative of tan root x. What is the derivative of tan x? Sec squared x. So what is the derivative of tan root x? That is sec square root x. Right? Sec square root x. The derivative of tan x is sec squared x. So here it is root x. So x is replaced with root x. Again, what is the derivative of root x? 1 by 2 root x. So that's the derivative of it. It's very simple, but only if you know the formulas. Okay. Now coming to the next one. F dash of x is equal to denominator into cos 4x into denominator into derivative of the numerator. Derivative of sine 3x is what? Cos 3x. That of 3x is what? 3. Right? So, the denominator into derivative of the numerator minus numerator into derivative of denominator. Derivative of denominator means derivative of cos of 4x. Cos of 4x is minus of sin 4x into 4. That of 4x is 4 divided by cos square 4x. Denominator square. I can just simplify and write. There is 3 cos 4x into cos 3x minus 4 sin 4x into sin 3x, the whole divided by cos square 4x. Got it? So that's it. Now coming to the next one. Understand the problem, children. Do watch the video twice or thrice. Only then you will be able to follow this in complete manner. So next one, f dash of x. Here I need to apply product rule, but each part of this function is a composition function. So there is a chain rule there. Here we have a chain rule from sine, sec of tan root x. First one, derivative of sec x tan x. Again, that of tan root x, sec squared root x. That of root x, 1 by 2 root x. That is, there is a chain happening, chain of derivatives happening. We call this as chain rule. Okay. So now, we have done these kind of questions in class 11. That's why I didn't emphasize it in more. Now there again we come to the composition function. It's a composition function. We have chain rule there as well as product rule. Both are happening simultaneously. So let's see. First function into derivative of the second. Now sine square x raised to the power of 5. Before I move on to that, sine square x raised to the power of 5 is same as sine of x raised to the power of 5 the square. Now what's the derivative of x square? That is 2x. d by dx of x square is 2x. Right? So I have this as the derivative of over here. It is 2 sine x raised to the power of 5 first. Okay? The first thing is the part. So 2 sine x raised to the power of 5. Next, what's the derivative of sine x? That is cos x. That is cos of x raised to the power of 5. Then comes x raised to the power of 5. That is what? 5x raised to the power of 4. You get it as 5x raised to the power of 4. So the first part is over. First function into derivative of the second. Plus second function, that is sine square x raised to the power of 5 is the second function. Into derivative of this. This is cos x raised to the power of 3 x cube. Cos x cube, not cos cube x. Okay, cos cube x is different. This is sine squared x. That is different. So here it is cos x raised to the power of 3. What's the derivative of cos x? Minus of sine x raised to the power of 3. That of x raised to the power of 3 is 3x squared. Okay, so now let me simplify and write this. This is equal to 2 times cos x cube into sine of x raised to the power of 5 into cos of x raised to the power of 5. Then 5 into 2, I can take it as 10 x raised to the power of 4. Right? This 2 into 5x raised to the power of 4, 10x raised to the power of 4. Then there is a minus here, so minus 3x square into sine square x raised to the power of 5 into sine x cube. Right? Sine of x cube. Am I clear? Sine of x cube. Sine of x cube, we can write it in brackets. That will be much simpler. Okay? Next one. F dash of x. Here. What's the derivative of root x? d by dx of root x. It is 1 by 2 root x. So here what do you have? 2 is a constant that is there. Root of cot of this, that is 1 by 2 root of cot of x square. Right? 2 into root of x, 1 by 2 root x. In the place of x you have cot of x square. Now let me find the derivative of cot of x square. What's the derivative of cot x? Minus of cosec squared x. Right? In the place of x it is x square. Now I will find the derivative of x square. What is the derivative of x square? 2x. So 2 and 2 cancels and I will get it as minus of, minus of 2x into cosec square x square by root of cot x square. Okay. So that's it. Go through this each of the question and try to understand it in more. This is cos of x cube. This is sine square x raised to the power of 5. Okay. So understand it, and if you have any doubts, you can ask us during the meet. Yes. Now let's see the questions. Okay. So the first question: if 2x plus 3y is equal to sine x, find dy by dx. Now 2x plus 3y is equal to sine x. This is our function. We are going to find dy by dx. 2 into derivative of x is what? 1. So 2 into 1 plus 3 into derivative of y is dy by dx. Derivative of sin x is what? Cos x. Right? So 3 times dy by dx is equal to cos x minus 2, or dy by dx is equal to what? Cos x minus 2 by 3. Done? That's all. That is what you find as dy by dx. Okay, so it is sine square y. So that is, that I can write this as sine y the whole square plus cos of xy is equal to pi, isn't it? It is for easier perception of the question. I have wrote it like this. So now this is 2 times sine y. That of sine y is what? Cos y. Since it is y dash, our dy by dx, plus derivative of cos x is what? Minus of sin x. So I have this as minus of sine of xy, right? Into, now I have to find the derivative of xy. X into y dash plus y into derivative of x is 1, and the derivative of pi is what? 0, constant value. So now I am going to club 2 sine y cos y, right? Here again there is a y dash, that is minus of sine of xy into x into y dash is equal to, this moves to the other side, that is y sine of xy. Am I clear? Y sine xy. So what is y dash? Y dash is equal to y sine of xy by, this is sine of xy by 2 sine y cos y minus sine of xy into x. That's it. So what did I do here? Sine y the square. This is of the form x square. Derivative of x square is 2x. So this is 2 times sine y. Derivative of sine y cos y. Since it is y, I have this as y dash. Right? Plus cos of xy, derivative of cos x is minus of sin x, so minus of sine of xy. Now that of xy, I will apply what? The product rule. Got it? And then I have simplified the bracket, and just what is asked in the question is to find dy by dx. So dy by dx, I have found it in this manner. Am I clear? Yes. Now we come to the next session of questions. If xy plus y square is equal to tan x plus y, find y dash. Okay. So now this is product rule. X into y dash plus y, that of x is 1, plus 2y y dash is equal to, derivative of tan x is what? Sec squared x plus y dash, that of y is y dash. Now I club y dashes together. X plus 2y minus 1 into y dash is equal to sec squared x minus y. So what is y dash? Y dash is equal to sec squared x minus y by x plus 2y minus 1. This is the value of the y dash. Now here you have sine inverse. Rather than finding the sine inverse derivative using the derivative of sine inverse, I will substitute for x is equal to tan theta. So it is much simpler now. So what do I get? Y is equal to sine inverse of 2 tan theta by 1 plus tan squared theta. Now what is 2 tan theta by 1 plus tan squared theta? Isn't it sine 2 theta? So I'll get it as sine 2 theta. So what is sine inverse of sine 2 theta? That is 2 theta, which is 2 into tan inverse of x. So what is y dash? Y dash is equal to 2 into derivative of tan inverse of x is 1 by 1 plus x square. Am I clear? So that is the derivative of y is equal to sine inverse of this. This is much easier and faster. That's why we use the substitution method here. Now coming there, do you know what will be substitute for x as? Again, x is equal to tan theta. So substituting for x is equal to tan theta, what do I get? I get this as cos inverse of 1 minus tan square theta by 1 plus tan square theta. Now, what is this value? Cos inverse of 1 minus tan square theta by 1 plus tan square theta. Okay, so this is cos inverse of cos of 2 theta, which is 2 theta. Again, which is equal to 2 into tan inverse of theta, which implies y dash is equal to what? 2 times 1 by 1 plus x square, or 2 by 1 plus x square. Now, coming to the next question. If y is equal to cos inverse of 2x by 1 plus x square. Now, when you have 2x by 1 plus x square, again, I'll substitute for x is equal to tan theta. Substituting for x is equal to tan theta, what will you get? Y is equal to cos inverse of 2 tan theta by 1 plus tan square theta. Right? Now, 2 tan theta by 1 plus tan square theta is what? Sine 2 theta, isn't it? It is sine 2 theta. So, cos inverse of sine 2 theta. Now, how will I convert the sine 2 theta into cos theta? I know that it can be written as pi by 2 minus 2 theta. I can write it as cos inverse of pi by 2 minus 2 theta. Right? Pi by 2 minus theta. Cos of pi by 2 minus theta is sin theta. So, I have written this sin 2 theta as cos of pi by 2 minus 2 theta. Now, this is equal to pi by 2 minus 2 theta. Why? Cos inverse of cos is getting nullified, pi by 2 minus 2 theta. This is equal to pi by 2 minus 2 into tan inverse of x. Now I find the derivative. Y dash is equal to derivative of pi by 2 is constant is 0 minus 2 by 1 plus x square. Am I clear? Minus 1 by 1 plus x square. So I have reduced this in sin 2 theta into cos of pi by 2 minus 2 theta. That's the only thing I have extra done here. Am I clear?